Hi guys, so today we're going to take a look at the second part of the lesson on graphing rational functions. And while we will not be responsible for graphing at the end of this lesson, you will have all of the tools that you need in order to figure out how to create a graph, all right? But today's focus is really going to be on finding the other key features and also reviewing how to find the ones that we did in the last lesson, being vertical asymptotes, horizontal asymptotes, and nulls. And you are going to see one graph at the end of this, so you have an idea of what these graphs could look like, but you will not be responsible for creating those graphs on your homework tonight, okay? So key features. What are the other key features of rational functions that we need to be able to find in order to create a graph? So the first is being able to find x and y intercepts, okay? And I'm writing if any because there's the potential, because of vertical asymptotes and horizontal asymptotes, that there might not be an x-intercept or there might not be a y-intercept. And we'll see that happen in an example or two. All right, so to find x and y intercepts, we do what we've always done. To find a y-intercept, we plug in x equals 0 and we evaluate for y. To find an x-intercept, we set the y equal to 0 and we solve for x. The other thing we need to be able to tell is where, if at all, can we cross the horizontal asymptote. In the previous lesson, you saw some graphs drawn where you were able to cross the horizontal asymptote and others where you were not. So today we're going to talk about how do you know if you can cross it, and if you can, where does that happen? All right, but we're going to talk about intercepts first. All right, so we are going to go through and find the x and y intercepts for both of these, but y intercepts are usually easier to find, so we're going to start there. So for f of x, to find the y intercept, I'm going to replace x with 0. So you can see I'm replacing all of the x's with 0, and we end up with 2 over negative 4. That reduces down to negative 1/2, so our y-intercept is the coordinate point, x is 0, y is negative 1/2. Okay, and that's all you have to do to find a y-intercept. Those should be pretty straightforward. X-intercepts are a little bit more thinking, but you've actually done this before when we were solving rational inequalities. Let's see if you can figure out how. All right, so x-intercepts, we do 0 equals the entire expression. So we can go through and we can multiply both sides by 3x minus 4 to try to isolate or think of it like cross-multiplying. And that's going to lead us to just have 0 equals 5x plus 2. So here's our little shortcut. When we were solving rational inequalities, we did the denominator equal to 0 and the numerator equal to 0. Well, to find an x-intercept, it's really just the same thing as doing the numerator equal to 0, because 0 divided by some other number will be 0, okay? So our shortcut from here on out to find an x-intercept, we do the numerator equal to 0, solve that. So if I solve 0 equals 5x plus 2, I get x equals negative 2/5, giving me the coordinate point x is negative 2/5, y is 0. And that's it for finding the x-intercept. All right. Now there can be more than one x-intercept, which you're going to see in g of x. But let's go back and do y-intercept first, because that one's usually a little bit easier. All right, so to find the y-intercept here, I plug in 0 for x again, and I end up with negative 9 divided by 0. But what's a number divided by 0? Well, we can't do that. 0 divided by something else, like if this was 0 over negative 9, well, that'd be fine. That would be 0. But negative 9 over 0, that's undefined. So what does that mean? That means that there is no y-intercept. That point is an undefined point. You can't plot it, you can't graph it, it's not even a hole. That means there's probably a vertical asymptote at x equals 0. Okay, so there's an example where you don't have a y-intercept. Now let's talk about the x-intercept. Again, we do x-intercept, the entire function is equal to 0. But we know that that's really going to turn into just the numerator is equal to 0. And this is a quadratic equation, so it has two solutions. In this case, plus or minus 3. So our x-intercepts are negative 3, 0 and positive 3, 0. And that's finding x and y-intercepts.